Here's example 4, and in this one, we're actually doing things a little bit differently. This question is asking, what is the equation of the graph that we see? And so it is an absolute value function because it's a v-shape. And when we are determining the equation, what we're going to do is we are going to follow this form, f of x equals a times the absolute value of x minus c plus d. And so to answer this question, what we have to do is we have to figure out what a, c, and d are, okay? And let's see. The best way, in my opinion, to figure that out is to first focus on finding c and d, because they're what move the vertex. And so we know that the typical absolute value function starts at 0, 0, but this one clearly starts right here, which is the coordinates 5, 3. So this one has been moved right 5 units, and it's been moved up 3 units. So let's see. It used to, so I'm just going to draw it here. It used to be at 0, 0, but it's moved right 5, and it's moved up 3. So if it's moved right 5, that means that C is 5. And if it's moved up 3, that means that D is 3. All right, and so we will put those into the equation in a moment, but let's look at the letter A. So what do we notice? Hopefully you notice that if we're looking at the letter A, we are going down, so that means that we have a negative. And if we just kind of take a look at the slope to this first point, you can see that we've actually gone down 3 and over 1, right? I'm going to go ahead and put negative just to remind us that we're going down here from the vertex to this next point. So that tells me that A, all right, let's just say we have a stretch, a vertical stretch of 3, because that's the vertical distance between the points, the first point and the second point here. And then it's also reflected upside down. So we still say reflected over the x-axis, because if it hadn't moved left or right, it would very clearly be over the x-axis. Right now it just might look like it's reflected upside down, but it's the same thing. So these together give us the letter A. All right, and so we know that A is 3 because of the stretch, and because it's reflected, we know that it's actually negative 3. So when we are plugging these in to the equation, we're going to get this. F of x equals, all right, so A is negative 3. So I'm going to say negative 3 times the absolute value of x minus c is 5 plus d, which is 3. And so if we were to simplify this, we would get this. F of x equals negative 3 times the absolute value of x minus 5 plus 3. And let's just do a little mental check. Let's make sure that this works. So looking at the negative 3 in the front, that would be a vertical stretch and reflection, which we can see on the graph. This says x minus 5. Is that good? Well, we're moving to the right, and remember that if we're moving to the right, that means we actually are going to see a minus in the equation. Remember, the letter C is always kind of the opposite direction that we would think, and then plus 3 at the end would make us go up. So it looks like it should work. I'm just going to take 1 point off the graph, and I'm going to check it. I'm going to take this random point right here, because I can see that it's on the graph, and it's 9, -9 are the coordinates, and I'm going to test it in my new function. I'm going to say, if I input 9, am I going to get -9? So we have -3 times, all right, input 9 minus 5, then we got our plus 3, and so we got to do the order of operations. So we have -3, and we do inside the absolute value first. 9 minus 5 is 4. Now we perform the absolute value, so we have -3 times the absolute value of 4, which becomes just +4. Now we multiply, so -12 plus 3, and -12 plus 3 is -9. So when we input 9, we output -9. And so you can see that our equation that we've come up with matches the graph that we were trying to match it to. So once again, this last part is just an additional way of checking to make sure that we've done it correctly. But here we have it. In the box here is the equation that matches the graph on the left.